This is the 8.8 exit ticket where we're going to practice converting between standard and vertex form. Number 1, rewrite the following function in vertex form. F of x equals x squared plus 2x minus 5. Remember, you need to complete the square to write this in vertex form. So the first thing we should do is we need to take our middle term and divide it in half. Remember, we have x squared and 2x, so we're dividing that middle term in half so we can start to make that square. So 2 over 2 would equal 1, okay? And so we're going to have 1 on each side here, so that means we're adding on 1 squared, which is 1 there. So our new square is x plus 1 squared. Okay, we have that minus 5, but because we added on that extra 1, we have to also subtract it, okay? The 1 squared, which is equal to 1, okay? So our completed square would be f of x equals x plus 1 squared minus 6. All right, next part, state the vertex of the function. So our vertex of the function is going to be -1, comma, -6. Okay, remember our formula is x minus h plus k, right? So whatever sign h is inside of here is going to be the opposite for the vertex, h minus k. So if you see +1, it's going to be -1 and then -6. All right, last part of this question, determine if this point is a maximum or a minimum. So the correct answer here is D. Okay, this is a minimum because the function is concave up. Okay, we have a positive value here in front of x squared, which is +1, which means we have a concave up function, which means that vertex down here is going to be a minimum, okay? All right, number 2. A high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t equals -16t squared plus 96t plus 6, where t represents the time in seconds since the ball was thrown and h represents the height in feet of the ball above the ground. Part A, at what height does the ball get thrown? So remember, this would be where time is 0, where we're starting. At what height does it start at? So because we're looking where time is 0, this is our initial value of our function. It's the same as the y-intercept. So time is 0. You can do this kind of one of two ways. You can plug in 0 to your function. You're finding when h is of 0. So when you plug in 0 to your function, that goes away, and you're left with 6. Okay, so 6 feet is the answer here. Okay, that's your y-intercept. Remember, the y-intercept is always just the number that's right at the end. Okay. All right. Part B, write the function in vertex form. So remember, that means we're going to have to complete the square here. Okay, first step to complete the square is if you ever have a number in front of the squared term, you need to divide that out first. So we're going to take out our -16. So we're left with t squared minus 6t minus 6 over 16. Just leave that as a fraction. Okay, second step, we take our middle term. We divide it by 2, okay, and we'll get -3. Okay, that means that here, right, we think about that little square, we have t squared minus 3t minus 3t, so this is going to be here. Okay, so this turns into t minus 3 squared, okay? And we still have that -6 over 16, but this little extra square we added is -3 times -3, which would be +9. So remember, since we added 9 there, we have to subtract it. Okay, now from here, all we have to do is distribute that 16 back in. So -16 here, right? We can't go inside the parentheses, so it's just t minus 3 squared. -16 times -6 over 16, those bottom and the top are just going to equal 1, right? So this turns into just 6. And then -16 times -9 is +144, okay? So simplifying this all the way down, we get -16 times t minus 3 squared plus 150. So that is our equation in vertex form. All right, part C, what is the maximum height the ball reaches and at which time does it occur? So that's asking us for the vertex, right? They're saying what time is the highest point, and that would be your vertex. So looking at our equation in vertex form, we can easily see our vertex is at 3, 150. So that means that 3 seconds. Okay, the ball is at 150 feet. That's what that means. All right, and then part D, what is an appropriate range for this function? Remember, range is talking about all of the outputs, the y values there. So in this case, the h values, okay? What's an appropriate range? So here the correct answer was C, 0 to 150. Okay, 0 is the lowest height the ball can have. Okay, and the max height we said was at 150. So this ball is, oh, we're not starting at 0, we're starting at like 6 here. Okay, the maximum height the ball reaches is 150 feet, and then when it lands on the ground, the lowest is 0, okay? All right, how do you feel about this exit ticket? Do you have any additional questions? Rate yourself on a scale of 1 to 4.